So as I mentioned yesterday, we've been partnering with Amazon Web Services and helping to put the event together here. They are our showcase sponsor, and Amazon Web Services will be delivering the keynote this morning. To deliver that keynote this morning, we have Arun Gupta, Principal Open Source Technologist at Amazon Web Services. Arun has built and led developer communities for over 10 years at Sun, Oracle, Red Hat, and Couchbase. And he's a founding member of the Java EE team at Sun. Arun is a prolific writer, has authored books, and more than 2,000 tech blog posts. He goes around the world delivering tech talks to conferences and communities all around the world. So please join me in welcoming Arun Gupta to the stage. Welcome.
Thank you. Good morning. My name is Arun Gupta. I'm very excited to be here. I work for Amazon. There are a few reasons for my excitement here. First of all, I work for Amazon. We have been helping customers build cloud-native applications for over a decade and helping them succeed. The second reason that I'm excited about here is because I am also the board representative for Amazon on Cloud Native Computing Foundation. So this is a topic that is very close and near to my heart, and I talk to customers about it quite regularly here. So this transition over here, in terms of going to modern applications and building cloud-native applications is near to both developers and operators, and which I understand is a good mix of this audience. So I want to give a huge shout-out to CloudBees for having us here. We're excited about the partnership. So let's get started. Now, before we get started, the third reason that I am excited is because I've spent a number of years at Sun, a few years at Oracle, and then at Red Hat. So there are a few folks, here in the audience, in CloudBees, that are working today at CloudBees. So I'm very excited to have been working with these brilliant minds over there. And this man needs no more introductions. He's Kosuke Kawaguchi, of course, the creator of Hudson, erstwhile, and now Jenkins. So Kosuke and I used to wander the halls of Sun Microsystems. We were in the same team. We used to wander the halls asking people, hey, you got a spare machine? And this is like 10 years back. You got a spare machine. We want to put it as part of the Hudson cluster. And of course, which is now Jenkins. So history behind, but it's all exciting, building CI/CD tool and building a lot more on top of that. So let's do a level set on what a modern application looks like. A definition that is well adopted in the industry is the one that is created by CNCF, essentially. And first, the application is containerized. What that means is the application is packaged together with its all dependencies. What that gives you is the ability for the application to be independent. It gives you reproducibility. It gives you transparency. It gives you resource isolation. So all those benefits of containers are available to you. The second aspect is, if you're running the application as a set of containers, then an application will have a lot of containers. If you're running hundreds and thousands of containers at a scale of hundreds of EC2 instances, it becomes difficult to manage the cluster and schedule the containers. That's where you need a tool like an orchestrator or Kubernetes kind of fits in very well. And of course, at Amazon, we have Amazon ECS and other technologies that allows you to do so as well. The third component is really the application, as opposed to deploying as a monolith, deploy it as a microservices-based application. So essentially, your components are segmented into smaller applications that gives you agility, and that also gives you the maintainability of applications. Of the three, the last one is the fundamental one. It comes along with adopting a container-based culture as well. So let's talk about three key issues that help you do the transition to modern applications, essentially. As we talked briefly, containers is a big part of it, and I'll talk more about that in a bit. We believe cloud is a big enabler for transitioning to the modern applications. It has some key primitives that helps you get onto that journey and expedite your journey to build a modern application. Culture is as much important, if not more important, than the other two pieces as well. So together, we think these three pieces are important you need to think about on your journey to modern applications. In terms of culture, what you really mean is how are you organized? How is your team structure look like? Now, as you think about these building blocks, containers, cloud, and culture, you think, how does that map to me, to the resources that already exist within my organization? Well, not very surprisingly, they map very well to people, process, and technology. They really very well align over there. So let's talk about each one of these and learn a bit more. Now, Jeff Bezos, CEO of Amazon, wrote in 2018 shareholders letter that the customer expectations, one of the things that he loves about customer is that they're divinely discontent. Their expectations are never static, they always go up. And over a period of time, what customers expect is value, selection, and convenience. And if you look at this latest DevOps State of the Report from 2018, that's what it talks about. That end of the day, this is what customers are expecting. They expect us to deliver a faster turnaround for solutions. Now, if you look at it over here, there are, in this DevOps State Report, they surveyed lots of companies, and what they did is they divided those companies into 4 different categories. And the categories were low, medium, high, and elite. Those were the 4 categories. And elite category is the category that was added this year itself. And what it does, it tells you the difference between the companies that are elite versus low-performing companies. Amazon is a customer-obsessed company, and we, of course, practice a lot of those DevOps practices as well. And if you look here, in terms of the difference between elite and low-performing companies, it is based upon software delivery performance, which basically leads to delivering value for your customers. The companies, you'll be surprised that this number, 2,555 times, is a pretty high number, but if you start looking into the data a little bit more scientifically, it starts making more sense. And it says the companies that deliver higher value, they deploy more code more frequently, they have a faster lead time from commit to deploy, they have a faster time to recovery, and they have a lower change failure rate as well. One of the Amazon customers that I would like to mention at this point of time is McDonald's. They have used technology like containers to work with Uber Eats and deliver food to their customers. So this is a very good combination of how containers technology is combined with process and people to deliver value to your customers. Now, before you start running, you have to learn to walk. We started learning containers when VMs were still a prominent technology. So we started saying, okay, you know what, I'm going to set up a cluster of VMs. On that cluster of VM, I'm going to set up my containers. So essentially, your container, you're seeing from a lens of a VM. We believe that's a stunted view of containers, essentially. So we need to make containers as first-class citizens. We really need to decouple the containers from the virtual machine itself. So what we think is that you no longer need to provision a EC2 instance or a VM in order to run the containers. When you want to scale containers, you scale containers, not containers and instances. In early days of VMs, if you think about it, you could assign an IP address to the host, but not to the VM. But then, in order to connect the two, you will create a bridge network. And the app developers got used to applying that phenomena and working with it. We wanted to bring the same concept when we are doing that with containers. So things like Elastic Network Interface. Now that can be directly attached to your EC2 instance. And a Kubernetes pod, for example, can be given a first-class IP address that is part of your VPC network itself. So essentially giving a first-class networking to containers. You also need to manage access at the container or the service level, not at the host level. And similarly, monitoring and logging. Yes, you need monitoring and logging at the host level, but you need it all throughout the stack as well. If my application goes down, I should be able to get visibility into that entire stack, down from application to the container, to the host, to the network, the entire layer. At AWS, we always think about how can we do undifferentiated heavy lifting for our customers so that they can focus on their applications. At reInvent, we launched this technology called as AWS Fargate, and it really allows you to focus on building applications, where once your application is ready or your Docker container is ready, once the container has been built or the image has been built, you can just give the image to Fargate and deploy the container over there. Now, the key primitives over there are no instances to manage. There are no operating systems to install. There is no versioning to be taken care of. You build an image, you run a container, and we auto-scale. It's a purely container-focused API, so there is no need for cluster provisioning, scaling, or managing the cluster, because truly you're just growing the container itself. And the important part is you only pay for the resources that you use. That's a very critical aspect of when you're building the modern applications. We truly believe that this allows you to focus on applications and operators to not worry about cluster provisioning, installing, and management. We think Fargate fundamentally changes on the way you build your application and deliver value to your customers. Another customer that I would like to mention over here is Veritone, that uses cognitive computing to analyze text, video, and audio data to provide actionable insights. For example, they look at the social media content and tell you whether it's harmful or could it be dangerous, and then tag it accordingly. So this leads to our first takeaway, or cloud-native principle, that the cloud-native application should be built using containers. They enable highly functional organizations to build and ship applications faster. And the last point about collateral damage is very important and critical, because you want to lower the rate of failure. The lower the rate of the failure is, the higher the rate of the innovation is. Because that way, you can have more frequent iterations. If you fail, then hopefully you fail fast, and then you move on, and then you continue to innovate. Now, let's talk about the role that the cloud plays in terms of building and transitioning your path to modern applications. The cloud really not only allows us to focus on modern applications, it also allows us to look at modern architecture, for example. 3 key principles over there. If you think about it, the first one is really pay as you go. Often you think about the transition to cloud really starts about saving the cost. That's typically the conversation starter. Now, yes, that is the conversation starter, but we really believe that the agility, the resiliency, the availability, the scalability, there are lots of other benefits of transitioning to the cloud. So for example, Dow Jones estimates that moving their data center to AWS would save them $100 million costs in operational infrastructure itself. So this is where companies like Dow Jones and many other customers are trading their operational expense, the capital expense, into operational expense. And that's exactly one of the reasons cloud is beneficial over there. The second aspect over there is self-service API-driven. And this is really targeted at both developers and operators in the audience. Now, if you think about from AWS perspective, there are 120 plus services that are available. From a developer perspective, what do you want? You want a database, you want a EC2 compute instance, you want some sort of a GPU instance. They're all a console or a CLI away. These services are all available in 18 regions and 55 availability zones. And we have already announced plans for 5 more availability regions around the world as well. And the 5th one literally came out this morning. And last but not the least, elasticity and scalability is an important aspect as well. Customers always used to over-provision in order to meet the peak demands of their business. But now they no longer have to do that, because there are concepts like auto-scaling groups where your applications, once you define your upper and lower thresholds, the application would automatically scale. And in cases like Fargate, you just grow up the application. In cases like AWS Lambda, if your application continues to grow, the application just automatically scales. Let's look at what happens when your applications were built using traditional data centers. You would build a data center with a finite capacity. You are offering an infinite capacity to your developers as long as it is within that finite capacity. You're also doing the undifferentiated heavy lifting. So it's in the back of your mind that if my business demands grow, I need to upgrade this data center. I need to refresh my hardware every 2 to 3 years. CVEs, patches, operating system installs, all that installation, provisioning, management of that becomes undifferentiated heavy lifting for you. You start wondering, do I want to be in the business of running a data center or delivering value to my customers? That's the question that comes to your mind. And last but not the least, innovation, or rather lack of innovation. Today, you are provisioning only VMs to your customers, but tomorrow, if your customers come back that, I'm building a microservices-based application, I want a relational data store, or a non-relational data store, or I want a graph database, or I want a GPU instance, or I want an edge computing service, or I want a messaging service. Do you want to be in that business for maintaining that? So that's typically, how you think about in terms of data centers, essentially. Now, a cloud-native architecture really allows us the flexibility and adaptability to only pay for the infrastructure that you need. You don't have to pay anything upfront. You use the services, often in most cases by the seconds, and then you pay for it. And what's the big benefit of that? You can actually dynamically make decisions on what projects and technologies you want to invest into, and then accordingly innovate on a much faster level, because the cost is non-prohibitive in most of the cases in that case. If an experiment goes wrong, you just terminate the infrastructure and move on. I would like to invite all developers sitting in their garage, in their basement, everywhere around the world, who are trying to innovate on top of the cloud, to come innovate on top of AWS. Airbnb was started like that. Up until 2 years ago, their entire IT infrastructure was managed by literally 2 guys, all running on AWS. That's the reason customers like Coinbase, Dollar Shave Club, Lyft, Slack, all of these startups, they started on AWS, and they continue to stay on AWS and continue to grow on AWS. So our takeaway point 2 over here is that for a cloud-native architecture, you only pay for what you consume and don't have to anticipate your usage. Now, if you grow, it's okay. You don't have to think about it. And hopefully you fail fast. And by fail fast, I really mean by fail forward. That means you learn from those experiments and then move on and continue iterating at a faster pace to deliver value for your customers. Now, with a cloud-native architecture, you no longer have to wait to file a ticket. Where you file a ticket, you wait for a hardware to be purchased, installed, provisioned, and then made available to you. If I go back to the days I was talking about when Kosuke and I used to wander the halls of Sun Microsystems, we would ask a lot of people to give us a machine so that we can put it as part of a Hudson cluster. Around the same time, people were actually saying, requesting their IT teams or IT departments to install or provision a hardware for them. And that's about the time when AWS was started. So you need to move away from that model where you file a ticket, wait for something to happen, and it should be self-service, on demand with no delays. Go to AWS console, click on it, EC2 instance provision, ready to roll. I'm provisioning GPU-based Kubernetes clusters very easily just because they're a CLI away from me. Now, the important part is also that the compute, network, storage, database, whatever comes to your mind, all those capabilities should be available and accessible to you in a very easy-to-use manner. So the fundamental change we are looking at over here is to move away from deploying, filing a ticket, and waiting for weeks, and just accessing it directly on demand and when we need it. And this really requires a change in the organization. It really requires very little human interaction and a lot of automation. One of the jokes that Kosuke and I used to make all the time is quoting Agent Smith here, basically, saying that never send a human to do a machine's job. If a machine can do it, why wait for it and wait for a human to respond? Let's automate the heck out of it and move on. Now, on the count of 3, so that we can do it one time only, if you are a Jenkins user, give me a yippee. 1, 2, 3. I just want to make sure you are as excited as we are about this partnership with CloudBees. I've been a Jenkins user for a very long time. We launched Amazon EKS, which is our managed Kubernetes service. Cloudbees Core, it was built on top of Jenkins, and it works very well with Amazon EKS. We are super excited by this partnership, and Cloudbees Engineering is continuously testing Cloudbees Core on top of EKS using deployment pipelines that are built on EKS itself. So we continue to recommend this to our customers, and we only expect this partnership to grow from here. So that brings us to our cloud-native principle number 3. And what that means is that the cloud-native applications or cloud-native modern applications and the architecture allows us to move to a self-service API-driven model. You no longer have to wait for filing a ticket, waiting for a response, and a human to be involved. A lot of automation is involved in there. The next principle for building cloud-native applications is really resiliency. Resiliency is the ability of a system to adapt to changes, failures, and disturbances in your environment. So there are 3 concepts when we look at resiliency: blast radius, there is loosely coupled architecture, and geographically distributed. So we'll talk about blast radius in a bit, but let's talk about the other 2 first. As discussed earlier, one of the core concepts of building cloud-native modern applications is loosely coupled applications. These applications are built using microservices architecture. A microservices architecture is a method in which a big, fat monolith typically is broken down into multiple smaller applications, and then they communicate with each other using well-defined API. Each application is independently deployable, upgradable, and that gives you the benefit of being able to use the right tool for the right job. Now, Werner Vogels, who's the CTO for Amazon, wrote an article on the 10th anniversary of AWS, and he talks about in an article that failure is a given, and everything will eventually fail, no matter how cheap or how expensive it is. Whether it's a network storage, whether it's a database, whether it's in-memory, whether it's wire, whether it's a monitor, it'll fail eventually. So we need to embrace the failure, essentially. As a Netflix customer, and I'm very glad they run on AWS, I like watching my episodes, like How Do I Get Away with the Murder? I want that to be a continuous streaming. And that's the reason it continues to work is because the way Netflix is deployed across 3 regions on multiple availability zones. So that gives me low cadence and high throughput. So the customer experience is the streaming can fall from HD to maybe low HD, but then I continue to get a top-notch customer experience. We also apply that concept of geographically distribution when we create the EKS control plane. You come to AWS console, you want to create an Amazon EKS control plane, we give you a highly available control plane. Let's talk a little bit about the blast radius part of it. We talked about the microservices concept here. You can really limit the blast radius for software-related incidents. By creating microservices-based application, you can really limit the blast radius of what is the impact if a particular service goes down. Think of a monolith application. If the application goes down, the entire infrastructure or the capability to your customers goes down. If you take like a shopping cart big application and break it into multiple microservices like customer detail, customer name, list item detail, if one of the microservices goes down, essentially what you have done is you have controlled the blast radius of the impact for that particular application. At least the rest of the application continues to work. That also helps you in isolation of the error, where the application might be going down. So you can quickly kind of start to narrow down on what could the cause of the failure be, and then start working on it accordingly. So that also leads you to a better MTTR, or mean time to recovery, so you can recover from the application faster, and then again, give a better experience to your customers overall. As developers and operators, our goal should be to reduce the downtime of our application to a bare minimum. So the fourth takeaway, essentially, that I will give up with, in terms of cloud-native principle is build applications using microservices. It is very critical to enable developers and operators to move more quickly with decoupled applications, and also support geographically distributed deployment models. AWS regions and availability zones certainly enables that. The last part that I want to briefly talk about here is culture. And I'm very excited that I report to Adrian Cockcroft at Amazon. Is such an awesome person here. But here's the code that he made, essentially. Now, one of the things that customers ask me all the time, how do you innovate at Amazon? How do I inject innovation in my company? How do I inject innovation in my culture? So at Amazon, the fundamental way we do innovation is we think of people as builders. We hire builders. And builders are the people who think about customer experience, who look at their pain point, and work towards solving those pain points. Builders are also people who think about the launch is only the start line. They have to listen to the customers, they have to keep reiterating, and then constantly reinvent for customers' behalf to provide the solution that matters for them. So as somebody who wants to build innovation in your company, you really want to nurture it. You want to breed it. There is no way to inject innovation into the company. So you just want to enable it and get out of its way. So to wrap it up, if you think about sort of your traditional infrastructure operators, which used to run the VMs or set up your clusters and manage your entire data centers, they are becoming more of a platform architect. Because essentially, with tools like AWS, you have so many services available to you. You are providing CloudFormation stacks on top of them, which allows your developers to be a lot more effective in terms of building applications on top of that. It also becomes important that the feedback that is coming from customer is incorporated into the system, and thereby creating a positive feedback loop to make the system better. So coming back to why building cloud-native applications matters. So what we have learned from last 3 years from our deep involvement in containers, microservices-based application is that the end of the day, the developers, small businesses, enterprises, IT shops, they want to deliver value to the customer. They want to focus only on the applications. And we know Cloudways think exactly the same way we do, and that's why this partnership is a great partnership. So in order to wrap up, what I'm going to say is the few key building blocks that are important for transitioning to modern applications are, as we discussed briefly, are containers, cloud, and culture. I'm particularly very excited on what you're going to do and build your modern applications with. So I encourage you to go and build your applications on top of AWS. Go build. Thank you.
Arun, thank you for a great perspective on cloud-native apps.
Thanks so much.
Thank you.
Bye-bye.